The internet as it is now is distributed, which is good, but it's also hierarchical. So a lot of the information as it travels throughout the internet ends up going through a few centralized nodes. When something's hierarchical, if you're trying to compromise it, take it over, whatever, it's a lot easier to take it over just by compromising the top level of the hierarchy than it is by compromising every single bottom node. Well, for example, in Egypt a couple years ago, they were able to disable the internet in the country just by knocking out 4 separate entry points into the country. And that took out the internet for millions of people. They didn't have to go into everybody's house and do it manually, they just hit these top level hierarchies. The motivation behind Shout is to provide a distributed public communication system that isn't hierarchical. And the way that we avoid hierarchy is by using ad hoc wireless. Ad hoc wireless lets us have devices talk directly to each other without the need of an intermediary router, which doing so removes the hierarchy from the layout of the network and makes it a distributed mesh instead.
Shout is a Twitter-like application, but messages go to people that are physically close to you instead of people in some social network. So the information flow matches the ad hoc network. Messages flow through kind of like gossiping in the real world. If you have some information, you can share it with somebody close to you, and if they find it interesting, they'll share it with somebody else.
Let's say there was something going on in the University of Michigan at Central Campus, something was going on. I could send the message, and people who are nearby me could forward that message to people nearby them. So the message could propagate different distances, and they can either do that by reshouting that message, or the message can automatically reshout depending on how recent it is the time you're sending that message.
Right now, Shout's really only used on the Michigan campus, but that's okay because there's lots of things you can use it for. If you have, say, free food in the library, you can just send out the message and that'll get spread word of mouth and people can show up and get the free food. If you're working on homework and you're stuck, you can send out a message like, hey, is anybody else working on my homework problem? And anybody else in the general vicinity that gets it is like, oh, I'm working on this also, and you guys can communicate that way. Like, you don't need to know exactly who they are, you can just send out the general area and anybody else working on it can help.
Currently, Android devices do not natively support direct device-to-device communication. In order to get around this issue, we've developed a back-end for Shout called Mains.
Mains is basically trying to emulate the true mobile ad hoc collection. It's monitoring each user's location and using that to decide who is collecting to whom.
When Android starts supporting this technology natively, we'll be able to just remove mains and we wouldn't have to do any major restructuring of applications that are based on this technology.
So one of the primary research questions that we're trying to answer with Shout is what are good methods for automatically relaying information to people in the network? Manual reshouting is interesting but requires a lot of effort from people. If we could figure out which information is interesting to which people, we could transmit that automatically through the network.
We're releasing Shout to the local Michigan community to get user data to develop better procedures for the ad hoc network that we'll hopefully be able to launch this off of in the near future. And with this data, like, you can just streamline protocols and make the whole system more efficient. Without the data, we don't really know what doesn't work because with a small test team, you can't really see what type of stresses and stressors will be put on the app infrastructure.